Okay, this is the second video in the 4.5 Modeling with Algebra lesson. Last video covered this handout. I've highlighted it to show you some keywords you should be looking for. So the word sum and increased by indicate adding. So let's go look. I've highlighted them in orange. Increased by, sum, older than, more than, increased by, together they earn. Right? Those are all things that show there's addition going on. Subtraction is highlighted in yellow. Decrease by, differ, less than. Decrease by, less than. Differ by, shorter than. Decreased by. Those are subtraction words. And then multiplication words are the product of or the word of. So let's look for those. 1/5 of a number, 7 times a number, the product of. Then you're looking for two numbers or more. The word of and multiplied by. Those are all multiplying words. You don't usually use division in these questions, but sometimes there's an example where you might say, 1/4 of something. That's the same thing as dividing by 4. You could do that. So those are the keywords you look for. And now let's move on with the next part of this lesson. Okay, so writing equations to solve problems. You need to have a let statement, you need to have an equation, you need to solve your equation, and you need to have a final therefore statement for word problems. That's proper form. Okay, let's look at this. 6 times, so I'm going to multiply 6 by something. 6 times the sum, I know that's adding. 6 times the sum of, so I'm going to add two things at least. A number, and there's the second thing, 15. Is my equal sign. So over here I'm going to multiply 6 times something. 6 times the sum of, so I know I'm adding something. I'm adding a number and 15. So I'm going to let x represent that number, x and 15. X is going to represent the number. Okay, so 6 times the sum of x, the number, and 15. Is equal sign 99 more than means I'm going to add 99 to something, and I'm going to go read the rest of the sentence to find out what I'm adding 99 to. 3 times the number. Well, 3 times, and the number is x. Well, there we go. Now we just have to distribute. 6x plus 120 equals 3x plus 99. I'm going to subtract the 3x from both sides. I'm going to subtract the 120 from both sides. I'm going to get negative 21 on this side, and I'm going to get 3x on that side. Divide by the coefficient of 3, and get x is negative 7. Therefore, the number is negative 7. That's the number that they were talking about. Okay, next. The sum of two numbers is 68. Well, if two numbers sum to 68, I'm talking about two different numbers. Also, the final statement says, what are the numbers? So I know I'm not talking about just one number. So in my let statement, I need to have something represent one number. Let me just read the rest. The sum of two numbers is 68. 6 times the smaller number is 8 less than half the larger number. So I'm going to refer to these numbers as larger and smaller. So I need something to represent the smaller. And I need something else to represent the larger number. Okay, so let's read. If two numbers add up to 68, I could write it like this. The first number plus the second number, total 68. So 68 is the largest of these three numbers. And if I wanted to figure out what the first number was, I could remove the second number from it by subtraction from both sides. So that means my first number could be found by subtracting the second number from 68. Or similarly, I could find the second number by removing the first number from 68. So I'm going to let x represent my smaller number, and then my larger number is going to be represented by the total. Removing the smaller number will leave me with the larger number. It doesn't really matter which one is larger or smaller at this point, because either this setup will work for either way. You could have said x is the larger number and 68 minus x is the smaller number. It wouldn't matter, but you do have to identify which one's smaller and larger in your let statement, because the next part talks about is going to lead to our equation. So now we read on. It says 6 times the smaller number is an equal sign, 8 less than half the larger number. So I'm highlighting this in blue because that's my equation. My equation is going to come from that relationship. I've already used the pink relationship to come up with my let statement, so I can't use it again to come up with an equation. I have to use the next relationship. So it says, what does it say? 6 times the smaller number. So I'm going to write 6 times the smaller number is represented by x is an equal sign. 8 less than. So I'm going to remove 8 from something. Dun, dun, dun. What am I going to remove 8 from? Half the larger number. So my larger number was 68 minus x. I need to put it in brackets to indicate, the whole larger number is going to be cut in half. I can either multiply it by half or divide it by 2. It's the same thing. I prefer to write it like that. And now I could just multiply both sides by 2 to clear the fractions and get 12x equals 68 minus x minus 16. And so if I add an x to both sides to get, oopsie, I shouldn't do that yet. Remember I said you should always simplify both sides before moving things. So now that I've done that, I'm going to go up here and remove the x by adding x to both sides. And then that leaves me here. So 13x is equal to 52. And divide both sides by 13. Leaves me x is equal to 4. The final part of this is to write therefore. Now x was 4. Go back to your let statement and see, oh, x was representing the smaller number. So therefore the small number is 4. But there's 2 numbers, so I also go back to my let statement and say, oh, 68 minus x was representing my bigger number. So 68 minus 4 is 64. So 64, the larger number. Therefore, the small number is 4, and 64 is the large number. And done. Okay, next we're on to question 3. The difference of 2 numbers is 12. So I'm going to use that for my let statement. The difference of 2 numbers is 12. Sorry, I'm going to try to go back a bit on this, and then maybe you guys can zoom in or use a computer instead of a phone to view it. The difference of 2 numbers is 12. Well, if 2 numbers add to 12, let's just go over here and think about that. If I have my first number and I have my second number, the way I get from the first number, let's say it's the smaller number, to the bigger number is I have to add 12 to it, because there's 12 between the two. And if I want to go from my large number to my smaller number, I would have to remove 12. So my large number is the biggest number of these numbers. And then I have the smallest number, and 12 is in between them. There's no total that's listed here. So in my let statement, I'm going to say, let x represent the smaller number, and let the larger number is going to be the small number plus 12 will represent the large number. If I wanted to have x represent the large number, I would have to subtract 12 from it to represent the smaller number. I find it easier just to do addition, so I usually start with x representing the small number and always add the difference to the little number to get to the big number for my let statement. Okay, next we move on to the rest of the relationship, which is going to give us our equation. When twice the larger is subtracted from 5 times the smaller, the difference is -9. That's my equation. So I'll write it over here. Equation. So let's go back and read that because there's a lot. When twice the larger. Now here isn't an equal sign yet because it's not always an equal sign, but often it is. but this, if you read the whole sentence, it'll make sense. When twice the larger is subtracted from 5 times the smaller, the difference is -9. So let's try that. Oh, I haven't done that one. Okay. Twice the larger. Twice. Oopsie, nope. Twice the larger is subtracted from. So this is the part that's being removed. Twice the larger. I'm going to subtract it from something. Subtracted from 5 times the smaller. Okay, so when I do that, I'm creating a difference, right? I'm subtracting two things. The difference is -9. So that's what I'm creating, a difference of -9. So then I just go back and fill in what those were. 5 times the smaller, take away 2 times the larger, will equal -9. And then we just group. And I'm going to get 3x equals -9. 24. And so I'm going to get 15. Divide by the coefficient of 2, and I get x is equal. Oh, really? Hang on, let's see if I mess this up. The difference of two numbers is 12. When twice the larger number is subtracted from 5 times the smaller, the difference between them is -9. So 5x subtract 2x subtract 24 equals -9. Oh. I see where I went wrong. It's not so bad. This is not 2x, it's 3x. Okay. And so then I get x is 5. Sorry about that. Okay, so I go back. Therefore, the numbers are 5 was the first number, because x was representing the smaller number. And to get to the larger number, I have to add 12. According to my let statement, to get the larger number, I have to add 12 to my smaller number. Numbers are 15 and 17, 5 and 17. Okay, next one. Find two consecutive integers. Oh, two consecutive even integers. That's a key thing. So we're going to look for find two consecutive even integers. Well, your let statement is going to come from that part there. Consecutive integers follow each other. To get from one to another, you just add 1. If I know that 7 is my first integer, then 7 plus 1, which gives 8, is my next integer, the next consecutive. But if, let's say, I start at the number 6 and I want the next even number, the next consecutive even number, I have to skip 7, and I know it's 8 is the next one. I have to add 2. Any even number plus 2 will give the next even number. Similarly, any odd number plus 2 will also lead to the next odd consecutive number. So you always have to add 2 to the starting one. So that's my let statement. So let x and x plus 2 represent the consecutive even integers. Doesn't really matter whether they're even or odd, it would be the same let statement. What's helpful by telling you that they're even is that at the end, if you don't get an even number, you'd be like, that can't be right. I should be getting even numbers. Okay, so there we are. Those are our two integers. Now it says twice the larger. So 2 times the larger is 14 less than something. 14 less than 5 times the smaller. So whenever you're subtracting, it's not necessarily done in order, right? Because they lead with the, 14 less than, but you should read that as I'm going to remove 14 from something and then go figure out what the something is. Okay, so now I'm going to go 2 times the larger. Well, the larger integer has to be this one. And the smaller one is the first one. And then we distribute. And I'm going to bring the 2x to that side through subtraction. And I'm going to bring the 14 over by addition. And divide off the coefficient of 3 to get x is 6. Therefore, the numbers are 6, and I'm just going to go check. X was 6. X was the smaller number, so that's 6. The next number is x plus 2, or 6 plus 2. So the numbers are 6 and 8. Always use your let statements to go back and figure out what this is. Okay, next page. Getting there. Okay, Mr. I don't know how to say this, Skivington operates a variety store with his 2 sons, Jerry and Coco. So we're talking about 3 people here. This guy, the dad, and the 2 sons. Okay, Jerry makes twice as much as Coco, who only works part-time. That's explaining why he only does that, but it's not really relevant. Mr. Skivington makes $200 per week more than Jerry. Okay, so now we know a relationship between all of their weekly payments. So we're going to our let statement's going to come from all of that stuff. So I'm probably getting a weekly video. Okay, I'm going to try to hold it up here. So we're going to I'm just going to do it really informally because I'm just to speed it up. So in my let statement, I'm going to say, I'm going to let Coco, Jerry, and Mr. S, and I'm going to be letting something represent for all of them their weekly income. For all of them. Okay, it's helpful if you figure out who makes the least amount of money. So I see here Jerry makes twice as much as Coco. So Coco is the least amount because the dad makes, more than Jerry. So I'm going to start with Coco being X. And if Jerry makes twice as much, he's not making like $2 more than. If it was more than, I'd add 2. But it's twice as much, so that's multiplying. So twice as much as whatever Coco makes. And Mr. Skivington makes $200 more than, so that's adding. I'm going to add $200 to whatever Jerry makes. Well, Jerry makes 2x. So that's what represents them all. X is Coco, 2x is Jerry, and the dad is 2x because that's Jerry plus $200. And then it tells us in the sentence, the rest of it says, the total weekly payroll is $1,450. Well, if you want to know how much you have to pay 3 people, you just add up the amount you pay each person together. So my equation, I should have done that in blue. I'm going to do it over here. Equation. The equation is simply add up Coco plus Jerry plus, and it should be in brackets to hold the whole person together. When we add those together, we get 1,450. So then we just, add them all together. We get 5x plus 200 equals 1450. 5x equals 1450 minus the 200. 5x equals 1250, and divide both sides by 5, and x is 250. Then we have to go to my therefore statement. We have to plug into this. Therefore, I'm going to do this really short form. Coco earns $250. Jerry earns double that. 2 times that is $500. And Mr. S earns 2 times 250, which is 500, plus 200 $700. I've done it short form, but you could write, Coco earns, Jerry earns, Mr. S earns. Okay, last one. This one's a bit different than the others. Uma works at a ballpark selling peanuts. She's paid $6 an hour plus 50 cents commission for every bag of peanuts that she sells. So that means she's earning an hourly wage, but she's also earning money a different way. She's going to earn 50 cents every time she sells a bag of peanuts. So I'm going to say her earnings, her total earnings, because there's two ways she's earning money. Her total earnings is determined by two things: the number of hours she works and how many peanuts she sells. So over here in my let statement, I would write let. I'm going to let H represent the number of hours worked. I'm going to let P represent the number of bags sold, bags of peanuts. So those are the two variables that I have. I've got two different things going on in this question. She's going to earn money based on the number of hours she works, as well as the number of bags of peanuts that she sells. So I can come up with an equation to represent her total earnings, knowing those two things. I know that she earns a rate of $6 for every hour. So if she works 1 hour, she gets $6. If she works for 2 hours, she gets 12 hours. So I know it's 6 times the number of hours. That's how much money she's going to earn just from her hourly wage. But she's also going to add to that the money she earns off of commission. She's going to earn 50 cents for every bag of peanuts. 1 bag of peanuts, she's going to add 50 cents. 2 bags of peanuts, she's going to add $1. We're adding 50 cents for every bag of peanuts. So that's the total earnings that she's going to earn. So in question A, it says find her earnings if she sells 42 bags of peanuts, 4-hour shift. 42 bags of peanuts in a 4-hour shift. So I know her total earnings will equal $6 an hour times the 4 hours that she works. And in addition to that, she's going to get 50 cents for each of the 42 bags that she sells. So she's going to earn $24 in an hourly wage, and she's also going to earn half of 42 is 21. She's going to earn $21 in commission. Her total earnings is a combination of the two. You have to add them together. Why did I think that was? So 45. Sorry, I made a mistake earlier. Okay, so $45 is what she would earn if she did that. Part B is a little different because Part B says how many bags of peanuts must she sell to earn $100 in 7 hours. So here we don't know the peanuts. How many bags of peanuts is the question. But we still have the same formula. We know her total earnings, but this time we know it's $100. $100 can be found by taking her hourly wage, which is $6 an hour, times her 7 hours. And add to that 50 cents for every bag of peanuts she sells. But P, we don't know. This is the idea of rearranging formulas from last time. Okay. Sorry, I'm just noticing something I've done somewhere else. Okay, so $6 an hour times 7 hours that she works is $42 for those hours, and she earns $100 plus 0.5p. I don't like 0.5. I'm going to change it. All right. I'm going to try to change it. I'm going to change it to half p or p over 2, just because I like fractions better. I'm going to remove the 42 from the other side by subtraction to get 58 equals p over 2. Multiply both sides by 2, and I get 116 as p. So therefore, she would need to sell 116 bags of peanuts. Is what she would have to do. So this formula, total earnings, $6 an hour plus 50 cents per bag of peanuts. There's 3 things here: earnings, hours, and peanuts. If you are given 2 of them, let's say hours and peanuts, and plug them in, you can solve for the third unknown, which was total earnings. Similarly, down here, you were given total earnings, and you were also given hours, and plugging those in only leaves one variable left in this equation to figure out, and that was peanuts. And you can rearrange the equation for whatever variable you want to find. Okay, good luck with that. See you next time.